All right. Good morning, everyone. I hope everybody is doing well, doing okay, given considering all things. It's been a crazy few days, and so I hope everyone is okay. I hope all of your families and homes are okay. Um, yeah, and I hope you're all staying safe out there. Um, this I didn't bother updating the the dates on the lecture slides. So I'm just gonna push. So this was originally what I had planned for Friday. I'm just gonna deliver it today. So it just the slide deck appears in the week one module, but the quiz you will see there's it's going to say week two Monday lecture view quiz. That's available under week two, and um and so that will be the quiz that you will answer today. Okay. Some of you might have just gotten added to the course. And if that's you, you can let me know in the chat. I think I went through and I tried to excuse everybody who missed, say, view quiz one from week one. But yeah, if you need to be added to the campus wire or anything like that, you can kind of type your email into the chat, and I'll send an invite to you. But yeah, I'll go through the roster and just make sure everybody's synced up with Gradescope and Campus Wire and whatnot. Okay, let's go ahead and take a look at the content. And so today we're going to talk about subsetting. Subsetting is how we select just certain values from a data structure. So frequently we're dealing with a list or an atomic vector or data frame, a matrix or something, and we just want to reference a subset, okay? Just a smaller selection and not the entire data frame. Um, Oh, and I do have a favor. If you're willing to turn on your cameras, it certainly feels nicer as a teacher. I appreciate that wherever you are. If you're willing to turn your cameras on, of course, you don't have to, but I do appreciate it. So it is nice to see your faces. Okay. Um, Okay, so let's talk about subsetting an atomic vector. Um, with an atomic vector, you can subset using positive integers, negative integers. We'll talk about all of these methods of subsetting a vector, and I think a lot of you are familiar with these already. But we'll kind of go through it. You'll notice the example vector I have, which is says X, 2.1, 4.2, 3.3, 5.4. The value after the decimal point is kind of the position in the original vector. So you have a 0.1 for the first element, 0.2 for the second element, 0.3 for the third element, 0.4 for the fourth element. Okay. All right. So I think we're familiar with this. You can just put in integers and something like that. So I can do a single square bracket. That's our subsetting operator. X single square bracket 3 comma 1. And it will select the third element 3.3 and the first element 2.1. There is a function order. Order will return the indices that you need so that the resulting vector is going to be in the proper order from least to greatest. So if you wanted to kind of sort these things, you can do that. Okay. Oh, that's kind of fun. I can see that some of you are in the same location as each other. So, um, uh, okay. You can have a single square bracket, 1 comma 1, and that will just, so here I've duplicated the indices that I want, and R will just repeat them. So here I'm going to get the first element 2.1 twice, right? Um, if you give it if you give R um, a value with a decimal, say 2.1 comma 2.9 or something, R is just going to silently truncate these and just give you the second. Okay. It doesn't do any kind of rounding operation. It just gives you the second element, right? So it's going to just truncate down to 2. 2.9 gets truncated down to 2. You're going to just get second, the second element multiple times here. This is rarely an issue because most of the time you're just dealing kind of with integers, but you know, floating point numbers don't behave like real numbers. So there could be, you could imagine a scenario where you do some kind of calculation and the result is say, um, 2.999999, where if you were working with real numbers, your result would have been 3, but because it's floating point, you end up with 2.999999. And in that case, if you use that result to subset, it would just get truncated down to 2. Okay. Um, all right. Single square bracket, if you put in negative values, it will just not return that value. So negative of 3, 1 will give you everything but the third and the first element. So here we get the second and the fourth element. Now you can't mix negative and positives because that is confusing. You're saying like, I don't want the first element, but I do want the second element. And you don't mention anything about the third or fourth element. And so R complains and it says, hey, I don't know what to do. Okay, it gives you an error. Um, I think we're also familiar with subsetting with a logical vector. A logical vector, you've got, true and false values, and basically R is going to return the values that are true, and not return the values that correspond to false. So here, if I have the logical vector true, true, false, false, we will get back the first and the second element which correspond to the true, and the true, but not the third and the fourth, which correspond to false and false. Here I have a logical operation, x greater than 3. X greater than 3, when applied to the vector x, will give me false, true, true, true. And so it will return back the elements that correspond to true. So the values where this statement is true, where x is greater than 3. Okay. If you give it a logical vector that is shorter than the vector that is being subset, it's going to recycle. So if I give it the vector true, false, it's going to recycle it to true, false, true, false. And so that will return the first and the third elements. Okay. True, false, true, false. Okay. If you give it a vector with missing values, it will always return an NA to the corresponding value. So here, if I have true, true, NA, and false, when I subset, it will give me true for 2.1, true for 4.2, NA for the third value, and then false for the fourth. It doesn't return the fourth, so we get an NA there. Okay, and if I have like a true comma NA, it recycles. It's going to be true NA, true NA. So 2.1, NA for the next value, true for 3.3, NA for the next value, and we get that. So the same kind of recycling rules apply. Okay. If you subset using an empty set of square brackets, that will return everything. It will return the original vector like a copy. It's not particularly useful in of itself for an atomic vector, but when you're dealing with, say, a matrix, and you can specify I want like all of the rows, but just these columns, or these rows, but only but all of the columns, you would use like a comma and nothing, or a nothing followed by a comma or something like that. Okay. And then also, you can, if you subset using a zero will give you a zero length vector. Again, this is not something that you generally do on purpose, um, but it can be useful for generating test data, especially when you want to test out your function. A lot of times your functions like break when you give it a zero length vector or something like that. And so if you want to kind of test something out, you can subset, vector x with a 0, and it will give you a zero length vector. X is a a type double, so it's going to give you a numeric vector. And I don't know why it says numeric. It should be like double zero, but there's no such thing as double zero. It's always numeric zero. They have integer zero and numeric zero, even though it's type integer and type double. So it's just kind of like a weird naming thing. But anyway, this is a zero length double vector, but it comes out as numeric zero. Um, with R, you can also take your vectors and provide names for the elements. This is kind of similar to a dictionary in Python, but it is most certainly not a dictionary. Dictionaries have other kind of and if you've never taken Python, no worries, but I just kind of want to make sure and say that a named vector is not the same thing as a dictionary because dictionaries are have hashable things. You can't have repeated names or keys in a dictionary, whereas a named vector doesn't have those kinds of checks. But anyway, you can um, name the elements of your vector, and you can kind of refer to your elements using the names, and you get kind of something similar here. So here I'm taking the vector x, 2.1, 4.2, so on and so forth, and I'm going to provide it the names A, B, C, D. And then once you have the names A, B, C, D, you can subset using those names. So you can say, hey, subset Y, giving with the names D, C, and A, and you get that. Here, I'm repeating the name A multiple times, and it gives me back the same element multiple times. I've got 2.1, 2.1, 2.1. If you give it a name that doesn't exist, you get an NA. And the names like R doesn't do any kind of like similar matching. It has to be an exact match. So here I have a named vector. One has the name ABC, two has the name DEF. And if I try to subset just using A or something, it's not an exact match. I'm going to get an NA. So it doesn't, like if you don't have it spelled exactly correctly with the exact same capitalization, it is case sensitive, so you don't get a match. All right, here's a useful application of looking up, subsetting with characters. You can create something called like a lookup table. Um, and in your homework, one of your exercises is to create a function where you're going to convert month names from one language to another. I suggest using a lookup table. I think this is kind of one of the most efficient ways. I mean, certainly there's other approaches to that problem, but I do think a lookup table is going to be useful. So the idea here is you have some entries and you want to kind of replace every instance of M with the word male and every instance of the letter F with the word female. And so here you've got kind of this original vector where I've got M, F, and U, and F, and F, and M, and so on and so forth. And then I want to replace every instance of M with male. And so I'm going to create another vector. This is a named vector with the vector entries are the values that I do want, male, female, NA. And then I give it names, M and F and U for those different elements. And so this vector is only length 3, and it feels a little strange, but I'm going to subset the shorter vector of length 3 with the longer vector X, okay? And X, kind of has these repeated entries, but that's fine. You can subset with repeated indices or repeated entries or repeated names. And so here, when I subset this short vector lookup with X, okay, I'm going to get kind of all of the values that correspond to everything that is in X. I'm going to get I'm going to get male that shows up when I look up M. I'm going to get female when I look up F. I'm going to get NA when I look up U, female when I look up F, and so on and so forth. This is what I get. If I just want to keep the values, I can unname the result, and this is what I end up getting. Okay. All right, so that covers atomic vectors. Let me go ahead and give you your first view quiz answer, which is the letter B. B as in bear. B as in bear is your first view quiz answer. B. Okay, let's talk about subsetting lists. Subsetting list is works in a way that is similar to subsetting an atomic vector, except you have a single square bracket and you have a double square bracket for working with a list. Okay, when you use a single square bracket, it always returns a list. When you use a double square bracket, it pulls out the components of a list. Okay. Um, an analogy I like to use is think of a list as a train. Okay, think of a list as a train where you have these different train cars. And when you use a double square bracket, it extracts the the object that's inside the train car. So double square bracket 5 gives you the object that's inside car number 5. Okay. Whereas single square bracket 4 through 6 will give you a train consisting of cars 4, 5, and 6. Okay. So here is uh, an example. Here's a X is a list. The list is represented with kind of the idea of a train. So it's a list of length 3. Okay. And the first element is a vector 1, 2, 3. Second train car contains a vector A. Third train car contains a vector 4, 5, 6. So when I do X single square bracket 1, I get back a train with just the first train car. If I do double square bracket 1, I get the contents of the train car, which is the vector 1, 2, 3. Okay. All right. So just a few more illustrations. Again, here is the vector, the train, the list X, length 3 list. Single square bracket 1 colon 2 gives me back the first 2 train cars. Single square bracket -2 gives me everything but the second train car. Um, Single square bracket 1 comma 1, or I guess vector C 1 comma 1 gives me back the first train car duplicated. Okay. Single square bracket 0 gives me a list with no train cars, as length 0 list. Okay. When you use double square bracket, it just pulls out the element within that train car. So here, if I do double square bracket 1, it pulls out the vector 1, 2, 3. This is a list where the train cars are named A, B, and C. So double square bracket 1 pulls out the element in that first train car, 1, 2, 3. Double square bracket A pulls out the element inside train car A, which is, again, that vector 1, 2, 3. Here I've got a single square bracket, and I got the vector ABB. And in this case, I'm gonna create a train consisting of car A, car B, and car B. Okay, and so now I have a train with 3 cars where car B has been duplicated. Okay. If I do double square bracket and I say double square bracket A comma B, I get an error, subscript out of bounds, okay? Um, and R does not let you just kind of like say, hey, I want to combine train car A and train car B together or something like that, okay? It doesn't let you do that with the subsetting operator, double square bracket A, um, it'd be a double square bracket with the vector A comma B. That's not going to work. Okay, you get an error. It says subscript out of bounds. All right, and what's actually happening is that when R sees double square bracket vector A comma vector B, okay, it's actually equivalent to doing X double square bracket A and then double square bracket B. Okay, and this is only going to work if you have a train kind of inside a train or a list inside of a list. So, it won't result in an error if I have a list where the first element or the first train car is named A. Okay. And then within that train car, I have another list or another train car, like a little train inside of a train. Um, and I have another car with A that has names, that has something named B. Okay, A and B here. So here, the top level structure says the top level is a list of 2, and then within that first train car, I've got a list of 2, or the first list element, I've got a list of 2. And then so here, double square bracket A, double square bracket B, looks inside the first list element and it sees a list of two, and then it looks inside the second list element and it sees the character B. And so returns the character B. And then doing double square bracket A comma B is the same thing. Anyway, I, I have this whole slide here just to kind of show you what's going on. I just say not recommended because this is confusing. Okay. This is not it it R is able to do this, but I do find it's confusing. I do think using just a whole bunch of double square brackets is a little bit easier to understand than the recursive subsetting. Okay. Let's just do some more examples here. All right, here I've got a list D, and the elements in the list are named A, B, C, and it's a list of three. Okay. And so I could do D single square bracket one. That gives me back a list with just one train car. And so that's going to be a train car named A, and it contains a list. And if I say type of D single square bracket one, the type is a list. Okay. Whereas if I use double square bracket, okay, D double square bracket one, I get the element inside there. Okay. And then the type of that is a double. And so you'll notice the output is there's a subtle difference, but these are the things you start to notice and pay attention to when you're dealing with R, is that when the output is a named list, you get $A and then single square bracket 1, 2, 3. Whereas when the output is just a vector, you just get single square bracket 1, 2, 3. Okay. Here's another list. This list has no names for its list elements or train cars. Okay, and we got 1 through A, letters 1 through 4, 5 through 1, 5, 4, 3, 2, 1. There's no names for these things. So how does R reference each of these things? There is a way to kind of reference every single value in there. And so if I do single square bracket 1, what it returns is a list. Okay. And the return is double square bracket 1, single square bracket 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I do L1 double square bracket 1, the output there is a vector, and the output is single square bracket 1, 1, 2, 3, 4, 5, 6, 7, 8. So the distinction in this output, there's only a little bit of a difference. But if the output starts off with double square bracket 1, that means the output is a list. So if the output starts off with double square bracket 1, or in this case, $ some name, the output is a list. If the output begins with just a single square bracket, then the output is a vector. All right. So make sure you start to recognize and pay attention to these little differences. Okay. It feels like these are just such, I don't know, trivial things that, and it's true, most people won't notice these things. But as you like spend a lot of time in R, then these little differences in the output are going to be key, are going to be cues to you as far as like what the output is. And these are going to be the things that you start looking for and paying attention to. Okay. If you do a single square bracket 1, single square bracket 2, the output is, it says null, okay? And what's going on here is when I did L1 single square bracket 1, I basically got just the train car, the first train car that contained this vector 1 through 8. And then I'm saying, hey, what is the second train? What's the second train car on this length 1 train? And there is no second train car. It's just a length 1 train. So that's why we get a null. Okay. Whereas over here, double square bracket 1 says, oh, I just want the vector inside that train car. Okay, double square bracket 1 is this vector. And then now I'm saying, hey, what is the second element inside that vector? The second element inside that vector is the number 2. Okay, so that's fine. All right, and again, this is the recursive subsetting, which I don't recommend, but this doesn't result in an error because this is equivalent to doing double square bracket 1, double square bracket 2. And in that case, we're basically asking for the second element inside the first element there. All right. So here, just to kind of make sure we can follow all of the subsetting, is I've got a train inside of a train, okay? Or train inside of a train car. So at the top level is I've got L2. L2 has 3 elements, okay? And the first element, the first train car contains list one itself, L1 itself. So the top level, when you ask for the structure of L2, STR, you get it's a list of three, and then the contents of that first train car itself is a list of three. So it's basically a train inside a train car. Okay. So how do we reference to all of these things? Okay, and all of these things are unnamed. So how do we reference all of these? And then so R just outputs like a whole bunch of square brackets. Okay, um, and it feels kind of wild at first, but then I get, just like everything else, the more you look at it, the more you study it, and the more you kind of familiarize yourself with it, you'll start to be able to understand all of these square brackets. But this feels kind of crazy, right? So L2, single square bracket one, what is that? That's going to return the first train car, which has a train inside of it. All right, so how do we explain that we've got a train car with a train inside? Well, or a list with a list inside. We get double square bracket one. This is saying we've got a train car. And then to say, hey, there's a list inside of that, we got double square bracket one, double square bracket one. And what's inside there? It's the vector 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then the second train car inside the first train, right? So remember, we've got the top level train, that first train car. What's inside there? There's another train inside. So how do we get the second train car inside that first train car? Okay, that's what this is. Double square bracket one, double square bracket two. And that's this vector ABCD. And double square bracket one, double square bracket three is the third train car inside the first train car. 5, 4, 3, 2, 1. Okay. And so when you say, hey, what is the structure of L21? It is a list of one. There's just one train car, and inside of that is a list of three. Okay. Versus if you do L2 double square bracket one, now you are getting the contents of that first train car, which is just like the miniature train. It's just the little mini train of length three. So here, this is just a list of length three, and we only have double square bracket one, double square bracket two, double square bracket three. This feels a little bit more manageable as far as like referencing the list. And this is what we have there. Okay, and then when you ask structure of L2, now we have it's just a list of three. It's just a list of three. It's just this is the little miniature train inside the bigger train. Okay, the actual train inside. All right, so if you can understand this slide, then you've got a good grasp on lists and list subsetting in R. And if this slide feels like wild and crazy to you, then take the time to kind of study and make sure you understand. Okay, so this is double square bracket one. So again, remember we have a train inside of a train. So we're going to say, look inside the first train car and give me the first element there. The first element there, though, remember, it's a train of three. We're getting back the train. So this is going to be a train car with the vector 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then if I say, hey, give me back that first train, give me the second thing, there's no second train. So we get a null here. Here I say double square bracket one, double square bracket one. We're saying, okay, go inside the first train car, and then look inside the train there and give me the contents of that first train car. And that's going to be the vector 1, 2, 3, 4, 5, 6, 7, 8. And then if I put in a square bracket two after that, it says, hey, give me the second element of that. And that's going to be the number two. All right. So this just kind of feels a little bit, like a lot, but yeah, that's how it goes. Okay. If you do double square brackets on an atomic vector, it kind of just extracts a value, and it works very similar. The difference is if your vector is named, it will drop the names. So here I've got just an atomic vector, and the names are ABC. Single square bracket gives me back the first element, the name A. Double square bracket drops the names. Okay. Oh, we got a hand raised. Charles, go ahead and ask your question.
Hey, does Do two consecutive single square brackets have any significance? I know in that last example, the second example, it returns null, but is there any case in which you would have two single square brackets and it would mean something?
Two single square brackets. Um, so uh for a list, well, okay, so for something like this is what would happen. If this thing was a vector though,
Yeah.
it could work. Um, but let's see. Um, and I guess it depends what the number is also, because you could keep doing single square bracket one, single square bracket one, single square bracket one, and it'll just keep giving the first element, and that's not a problem.
Oh,
Um,
interesting.
yeah,
I didn't know
and
that.
then this um yeah, so a lot of times this kind of notation th this is kind of like um I don't know, not super great, but a lot of times, generally you'll have like things with names, and you'll see something a little bit more commonly will be something like you'll see like $ A, and if $A contains a list, you might see like $A, uh, you know, something else, right? So, like LM, like the output of LM is a big list with like lists and lists and things. So I think you can do like $, the output of LM, $coefficients, something else or something, and you can reference like things nested inside of other stuff there. But this is just kind of like if nothing is named, how do you reference like, oh, I want the fourth thing and the third thing and something like that. And there's a way to do it.
Yeah, yeah. But dollar sign is kind of like synonymous with double square
Yeah,
brackets.
it's like double square bracket and it's for using names, which is when you need to reference things, like names are handy, right? It's easier to talk about, student Joe Bruin versus fourth student in the fifth class or something like that. Um okay. So anyway, that's what we have.
Thank you.
You got it. All right. Double square brackets on atomic vectors. There's a little bit of stuff that happens when you give it like things that are out of bounds or things that don't exist. So here I've got an atomic vector, length 3. You can ask single square bracket, what is the fifth element of the length 3 vector? And single square bracket, you get back an NA. It says, hey, that there's no fifth value. That's an unknown thing. Okay. But if you do double square bracket 5, okay, you get this subscript out of bounds error. Okay. And you're saying like, hey, give me the fifth element, and there's only 3 elements in the vector, and this one will return an error. Okay, so this one returns unknown, missing. This one returns an error. Okay, so that's something to be aware of. If you give it a length 0, okay, in a single square bracket, you get back a length 0 result, right? X is an integer vector, so we get back a length 0 integer vector. If you do double square bracket and you give it a 0 or a null, um, you get back um, you get back an error, right? You get an error, so it stops the code and says, "Hey, I can't continue on." So these are some differences. Okay. Some similar stuff happens when you're dealing with lists and out of bound or null indices. So here I have a list, length 3, and if I say, "Hey, give me the fourth element in this list of length 3," I get back a list containing null. Okay. If I say, hey, extract out the fourth element, okay, from this list theory, right, with the double square bracket 4, then I get a subscript out of bounds. Okay. So again, subscript out of bounds is a common error that you encounter. This often happens when you're running a loop and you're doing like for I and 1 through whatever, 50 or something. And I reaches a point that is higher than, the length of the thing that you're trying to subset. So, sometimes like you have a list of length 3, and then when I hits 4, you're going to get subscript out of bounds. Okay. But it's not going to tell you 4. It's going to say like L1 double square bracket I, subscript out of bounds, but that's what's going on anytime you see that error. Here, L1 subset 0 or subset with a null. Basically, I get a list with no train cars. Okay, so I just get an empty list versus if I say L1 double square bracket null or a 0 there, then I get an error. It says you're trying to select some less than 1 and you can't do that. Okay, let me go ahead and give you your second view quiz answer. And today's second answer is the letter D. D as in dog. D as in dog is your second answer. All right, let's talk about subsetting matrices and arrays. And I think we're familiar with subsetting matrices, but I'm just going to kind of run through these and we're going to work through some of these things quickly because, again, I think you're familiar with a lot of this stuff. Okay, so probably the most common method is subsetting with a multiple vectors. So here I've got a matrix, a 3 by 3 matrix. Um, I've got rows 1, 2, 3. Decided to give the columns some names, A, B, and C. And so, you can say, hey, I want rows 1 and 2, comma, nothing. That's going to be, I want all of the columns. So you get rows 1 and 2 and all 3 columns, A, B, and C. You can give it a logical vector, true, false, true. So I want the first row, not the second. I want the third row true. Give me columns B and A, and that's what we get in that order. We get column B and column A in the first and third rows. This feels a little bit weird, but it is valid. You can say, give me none of the rows and all but the second column. So we get column A and column C. We don't get the second column, and we get none of the rows. And so this is a matrix with no rows and 2 columns. All right. But yeah, that's what you have. Um, when you subset a matrix, the default behavior is to simplify down to a vector if it can. So, A itself, the matrix A is a matrix. It's not a vector. But if I say, hey, just give me the first row, okay, I get that first row, 1, 4, 7. It carries along with the names A, B, C. And this is not a matrix with 1 row and 3 columns. It is just a vector of length 3. So R kind of has this simplifying mechanism, which is handy, but sometimes you don't want that. Sometimes you want to preserve the matrix, and so there is a way to do that. But its default behavior when you just say, "Hey, give me row 1," it's going to simplify down to a vector. Here's a matrix, a 5 by 5 matrix with the first 25 letters. So sorry, letter Z, but we go A through Y, and we got 5 rows and 5 columns. Okay. Now remember, internally, um, R stores a matrix as just an atomic vector with dimension attributes. So so this is just a length 25 vector. If you remember back to last week's lecture, I said, hey, here's a vector and I'm going to give it some dimension attributes and it became a matrix. And then if I delete the dimension attributes, it's back to a vector. Internally, you can just kind of say like, hey, give me the 8th and 9th elements. Okay. This does not give me row 8, column 9. This is just give me the 8th and 9th elements in this thing. And so it treats it like an atomic vector starting, and it goes down the columns. So the 8th element is H, the 9th element is I, and we get that, the 8th and 9th element. This is also interesting. With a two-dimensional matrix, you've got rows and you have columns, and you can provide a set of coordinates. And so you can subset a matrix using a matrix, or using a set of coordinates. So here I can give it I'm going to give it a matrix with 4 rows and 2 columns. And I want to select row 1, column 5. Okay, row 1, column 5 is the letter U. Then I say I want row 3, column 1. That's going to be the letter C. I want row 2, column 3. Row 2, column 3 is the letter L. All right, and so I could specify I want these 4 letters, and these are the coordinates of each of those letters. I can give it the coordinates of each letter there. Okay, and so we can select letters that way. And with a matrix, with an array, a 3-dimensional array, you can do something similar. You would have to provide it 3-dimensional coordinates. Okay, so here I've got 12 elements arranged in 2 by 3 by 2. Okay, And I could say, hey, give me row one, column two, layer one. Okay. And that's going to give me 3. 2, 3, 2 is going to give me, 12. So this is how we're selecting elements using a matrix or a set of coordinates, set of 3 coordinates for each element. Okay. Um, all right, we gotta work a little bit quickly. With data frames internally are stored as lists and um, um, but they also kind of have this two-dimensional structure. So you can subset a data frame the way you would subset a list, like a one-dimensional structure. You could subset a data frame the way you would subset a matrix. Okay. So here I've got a data frame, columns X, Y, and Z, rows 1, 2, 3, 4. And here I'm going to say, I'm going to give it a subset like a matrix, which rows I want, which columns I want. I want it's comma 0, so I want all of the columns. Which rows do I want? I want the rows where this statement is true. So I'm going to say df $y, column y, divisible by 2, or is mod 2 is equal to 0. So it's going to be true for the first row where y is 4. It's going to be false for y is 3, true for y is 2, false for y is 1. So we're going to get back the rows where column y is divisible by 2. Okay. Um, Here I can say, give me X and Z. Give me basically elements X and Z in the list. And so I get just columns X and Z. So in a data frame, the list elements are basically the columns there. And then and here I can do comma X and Z, and this is saying all the rows and the columns X and Z. So these two things are pretty much the output is like the same. Okay, give me elements X and Z. Give me and this says give me all the rows and columns X and Z. Okay, the difference here happens when you kind of work the other way. Here, if I say give me rows 1 and 3, comma, rows 1 and 3, comma, all of the columns, I get rows 1 and 3. However, if I omit the comma, and if I do df 1 and 3, I get columns 1 and 3. Okay. So this will give me columns 1 and 3, and this will give me rows 1 and 3. So including the comma here makes a big difference, whereas back on these slides, the comma made no difference. Okay. But here the comma makes a big difference. Okay, when you have named columns and you select with single square bracket returns a data frame. Okay. And if you put in comma, okay, X, that will return a vector. All right. So data frame single square bracket X will return a data frame with one column X. Data frame square bracket comma X will return uh, that column, but simplified as a vector. Dollar sign returns just a vector. Double square bracket returns just a vector. Okay, so just be aware of how these methods will return vectors, and this one will return a data frame of one column. This kind of nature of simplifying versus preserving appears in other places as well, where R will often simplify things if it can. Otherwise, it preserves it. So with we saw this with the named vector. Single square bracket will keep the names. Double square bracket will drop the names. Um, with a list, single square bracket returns still a list. Double square bracket extracts out the element, and so kind of simplifies it. With a factor, a single square bracket will keep all of the levels of the original factor. So here I just single square bracket down to the first element. So there's only level A being represented in the factor, but it preserves all of the different levels that existed originally, A and B. Where here, single square bracket, and it feels a little bit strange, but you can put in a comma and then optional arguments. And so you can say drop equals true. And here it will drop any of the unused levels. Okay. Here I've got a matrix. And here I'm going to say I want row 1 all of the columns. So the original matrix A is a 2 by 2 column. Um, I'm sorry, 2 by 2 matrix. Um, and here I'm saying I want row one, all of the columns. So I get a 1 by 2 matrix here because here I'm going to say drop, comma, drop equals false. So again, it feels a little strange, but you could put in another comma. So you have which rows, which columns, and then you put in a comma, optional arguments. The optional argument is going to be drop equals false, and that preserves the matrix structure. So the original matrix was 2 by 2. After I select one row, it's going to be a 1 by 2 matrix. This preserves the matrix structure. If you don't include this argument, comma, drop equals false, then it simplifies down to a vector. Now it's a vector of length 2 with elements 1 and 3. Okay. With data frames, when you subset it like a list with a single square bracket, it remains a data frame. Double square bracket will extract out the column and you just get the vector. Okay, let me just show you a couple quick examples of common mistakes and things that go wrong. So here, there is a data frame in R called Motor Trend Cars. These are like cars from the 70s. And so like if you look up the Hornet Sportabout, it's like this, it's like a car that's like straight out of a 70s movie or something like that, okay? But anyway, we've got these cars and and let me just show you a few things. Okay, if I do something like empty cars subset, empty cars $cylinder less than or equal to 5, because the intention is I want to get the rows where the cylinders is less than or equal to 5. So, I want the Datsun with the 4 cylinder and the Merc, I don't know what that is, with a 4 cylinder and things like that. If I do it like this, I get an error. What's going on? It says undefined columns selected. What's going on is that I didn't include a comma. And so now it's when you don't include a comma, it's trying to select columns. Okay, it's trying to select columns. And so this logical vector goes something like false, false, true, false, 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 true, true, false. Okay, and eventually, I don't know how many columns there are, but if the original data set has like 50 rows, and let's say element 50 is true, it's going to try to select the 50th column because the way I've specified it here, it's trying to select columns. So that's why I get undefined columns selected. Okay. Um, I fix it by including a comma, and this tells R, oh, I only want to select the rows. I want to select the rows where this statement is true. Okay. And it's going to be true for, the Datsun and the Merc and the Fiat and things like that. Okay. Um, the Honda Civic, 30 miles per gallon, 52 horsepower. Look at that. 52 horsepower Honda Civic. Okay. Um, Here I want to select where the cylinders is 4 or 6. Okay, so I do empty cars $cylinder equals 4, equal 4, vertical bar for or 6. And yet when I look at the results, I get cylinder 6, 6, 4, 6, and I still get the 8-cylinder Hornet Sportabout. Okay. And the 8-cylinder Duster 360. So what's going on? Why is this selection not working the way I wanted? Okay. Well, what's going on is this OR operator is a logical operator, and it's expecting logical elements. And so on the left-hand side, we do have a logical statement. It's going to be true or false, 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 true, false, 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 true, whatever we have there. On the right-hand side, we don't have a logical statement. We just have a number, the number 6. And so the OR coerces the number 6 into a logical value. Anything other than 0 gets coerced into true. So the 6 gets coerced into true. So basically, I've got a vector of true, false values or true. So that's just going to be true for everything. It's going to be true for everything. And that's why it's giving me all of the rows. So if I want this to work, I have to do empty cars $cylinder equals 4 or empty cars $cylinder equals 6. And then I've got a true false vector on the left and a true false vector on the right. And then we can select things correctly. Okay. R has has a in operator, which is going to be preferable. And you would want to do something like percent in percent 4 comma 6. This is probably the preferred method. I just put it into the chat as far as selecting things that are different. Okay. All right, one more. Here again, I left out the comma. So this is trying to select columns. It's trying to select columns 1 through 13. We don't have 13 columns, so that results in an error. Including the comma will select rows 1 through 13. All right, let me give you your third view quiz answer. The last view quiz answer today is the letter E. E as in elephant is our third view quiz answer. And that will be it for today. We are online for the rest of the week. Stay safe, everybody. I hope you guys are all doing well. And if there's anything I can do to support, I added a couple extra days for homework one for its deadline. I don't know if that's going to make a difference. If you need anything else, just let me know, and I'll try to work with you. Anyway, stay safe. We'll see you online on Wednesday. Um, and have a great rest of your day.